Hey guys, my name is Tom. This is my friend here, who's always smiling. You should be too. And in this video, I am going to show you how to find the normalizing constant for a probability function. And this is for a joint PDF. So imagine you are given the following. F of xy equals the following: c times something like x plus y. So this is a function of two variables, x and y. We want to ensure that this function is a probability function, so we have to find the c here that will make the sum of the probabilities equal 1. So at first that is not a very meaningful statement, so let's take a look at a picture and say also that you're told that the x's and y's are allowed to change between the following values. 0 is less than or equal to x, which is less than or equal to 2, and then 1 is less than or equal to y, which is less than or equal to 2. Okay, so these are the conditions on x, and this is the condition on y. So the first step to make any sense of this is draw a picture and label all the points. This way it will seem more concrete and you can handle it more easily. So this is our xy coordinate grid. Mark points on the grid and keep them evenly spaced and big. 1, 2, 3, 4, and of course this is the x-axis and this is the y-axis, and of course this is the origin. So 1, 2, 3, 4. Now let's plot these points. Let's mark them in the grid. So how do we do this? Well, the way to do it is as follows. Notice x goes between 0 and 2 and y goes between 1 and 2. So fix your x at 0 and then let y go from 1 to the number 2. Okay, so that's this point, and it might be helpful to mark the coordinates here. So the coordinates of this point are 0, 1. The coordinates of this point are 0, 2. Okay? So I have fixed the x, but I am changing the y from 1 until it goes up to 2. What you want to do then is take your function and evaluate it at this point and evaluate it at that point. And you've got to keep the c. The c multiplies every value of the function. So we will have c, and then x is replaced with 0, but y is replaced with 1. So that just gives you 0 plus 1, which is 1. So you have 1c at that point. Okay? At this point you will have c, and once again x is 0, but y is 2. So you'll end up with 0 plus 2, which is 2. So that's 2c. Or c times 2 if you like, okay? Alright, so now you advance the x over to 1. And then you once again mark the point. See how carefully I'm doing this and neatly? Okay, this is a very structured process. It doesn't have to feel chaotic, or you don't have to be unsure of yourself. Okay. So you have fixed x at 1, 0, 1, 2, 3, 4. Okay, you fixed x at 1 and you've let y vary between 1 and 2. So that is now the point 1, 1, and the next point up here will be 1, 2. evaluate the function at the point 1, 1. So that means c, and you replace x and y with 1 each. So that's 1 plus 1, which is 2. So you end up with c times 2. At this point, you replace x with 1, y with 2. That gives you 3 as the sum. So you end up with c times 3. Let's finish up this point and that point. The coordinates of this point are 2, 1. The coordinates of that point are 2, 2. And what we have now is when x is 2 and y is 1, you add them, you get 3. So you end up with c times 3. That's coming from the function, right? X plus y. Same thing up here. You add up the 2 and the 2, that gives you 4. You multiply it by the c. So you end up with c times 4. So now that we have all of this in place, we apply one of the most fundamental concepts in all of probability, which is the probabilities of all the points have to be 1 once you add them together. So in our case, what this means is the following. You will take the c's and set them equal to 1 and solve for the c. So let's count them. This is 1c, 2c. So that's a c plus 2c from there, plus 2c from here, plus the 3c from this one, plus the 3c from this one, plus the 4c from this one, and all of this equals 1. Okay? Once you have this, you solve for the c by adding up. So here we have to be careful because there's quite a few of them. I'm going to place the 1 here so it's easy to see. Alright, so at this step, let me grab a calculator so I don't make any silly mistakes. The easy things can get you, as you know. Alright, and you see he is still smiling, so you've got to be smiling, you see? There you go. Let's add these up. We have 1 plus 2 plus 2 plus 3 plus 3 plus 4. All of that equals 15. So what we have now is 15c equals 1, which means that c equals 1 over 15. Once we find the c, and we find it in this case to be 1 over 15, we have the following we can do. We can take our function and rewrite it in the more concrete form, replacing c with 1 over 15. So let's do that now. F of xy equals 1 over 15 times x plus y. So this is our probability mass function, which has been normalized, which means that the sum of the probabilities at each point is 1. That is what it means to normalize a function like this, okay, in the context of probability. So with this in place, the next kinds of questions you might answer are the following. I will draw a little box here to separate all the previous work. Okay. What is the probability, for example, the probability that x equals 1 and y equals 2? How do we answer this question using the information we have found? Well, we have two options. We can evaluate the function here, so that would be f of 1 comma 2, which is equal to 1 over 15, and then you replace x with 1, and you add to it the value of y, which is 2. So what you have is 3 over 15. So the probability that x is 1 and y is 2 is 3 out of 15. The probability, for example, that x is greater than or equal to 1, and let's see, I'm looking for another example, and y is less than or equal to 2 is a little different. Well, how would we find it? This is a matter of adding things up in the following form. And I could use the double sigma notation, but I know you've got to have some, grasp of sigma notation in your head at first. Let's take a more intuitive approach. Well, let's take a look. It says x is greater than or equal to 1. So there is your value of x being 1, okay? And then it says y is less than or equal to 2. Alright, so if I choose this and this, okay, do these 2 points make this condition true? Well, x is equal to 1, so that is true. And then y is less than or equal to 2, which means that occurs when we have this, right? At these 2 points. So that means we will have 3 times c plus 2 times c. Okay? Now I am answering this question in terms of c rather than evaluating the function, because we know that c is 1/15th. So we can do it that way. As another option that I'm showing you, okay? Now, go over to the right and ask yourself, is x equal to 2 greater than or equal to 1? It definitely is. Then that is true. The first condition is true. And then y is allowed to be less than or equal to 2. So it's either this value or that value. So to this we will add another 3c, and then we will add the 4c. So what we have, add up the c's, we have 3 and 2 is 5, and 3 is 8, 8 and 4 is 12. So we have 12c, but we know that c equals 1 over 15, so we have 12 over 1/15. So we have 12 over 15. Okay. So that is the probability for this one. This is the probability for the previous one. And there you go. So this is a very detailed analysis of first finding the normalizing constant, graphing the picture, understanding how to find the normalizing constant, and then being able to either use the function to find the probability or to use c to find the probability. Either one works as long as you feel that you can use it. You have options available. Okay, so thank you for watching. Don't forget to smile. See, this guy came over here, he looked at this, bent his head, he was like, what is going on with these symbols, man? Okay. At first it looks intimidating, but if you do this a couple times, I'm telling you, it's fairly mechanical. Okay, so you've got to believe that. Thank you for watching and have an absolutely amazing day.